Alright, hello, my name is Logan Leone, and for my project I actually have two topics. The first one being PyPy, and the second one being PyQt. We're going to get started talking about PyPy first. PyPy is an alternative implementation of Python. It has its own specific advantages to the main Python language. Those advantages are that a lot of Python programs tend to run much faster when you're using PyPy, and they use a lot less memory when you're using PyPy. Um, PyPy is also highly compatible with existing Python code, so it's pretty easy to make the switch over. The performance gains that PyPy offers are based on what kind of code you're working with, though. So it depends on the kind of code you're writing, whether you get very high performance gains or pretty negligible performance gains, and we'll see that later on. So this shows a lot of the differences in speed that PyPy can offer, and like I said, it's heavily dependent on the kind of tasks that you're performing, and on average, PyPy is 7.6 times faster than Python, but in certain cases it can be many times faster than that. Um, so the thing that makes Python or PyPy so much faster than Python is the JIT compiler that comes with it. So PyPy has been improving its speed since its inception and is going to keep getting better the more and more it's updated if this graph is anything to be followed. Um, and the creator of Python, Guido van Rossum, even said, if you want your code to run faster, you should probably just use PyPy. And I think that's a pretty substantial claim considering he's the one who created Python, and he's saying if you want it to be faster, you should just use that. So PyPy's speed increases will show the most on programs that are running a large amount of complicated code, which is a pretty good majority of Python. But on things that do a lot of complex computations and such, and running complex functions, that's where PyPy will show the biggest differences for you. But for very short processes, the JIT compiler won't have very much code to optimize, so speed differences won't show up as much. Um, and if most of the code is spent in runtime libraries instead of actually like computing things, then it can't speed that up very much because that's just going and grabbing information. So we have an example here of the differences that PyPy can make versus Python running a simple program. So let's watch this. Okay, so to clarify that program, um, it measures coin flips up to a certain number, but you could see in PyPy it ran in just above 5 seconds, and with regular Python, it took an entire minute to run. That's a 20 times increase in the speed when you're using PyPy, so it can be a very, very big difference when you're doing computation-heavy programs. One of the other important advantages that PyPy offers is memory usage. So when you run this program on PyPy's interpreter with n equaling that number, the total amount of RAM used is 247 megabytes, and it takes only 10.3 seconds. Well, the same program run on CPython consumes 684 megabytes, and it can take 89 seconds to complete. So not only is PyPy a lot faster than Python, but in most cases it'll also use fractions of the memory that Python takes to do the same exact tasks. So, uh, compatibility. Regular PyPy implementations in Python language in version 2.7.13, but Python implements the Python language in version 3.5.3. All the core languages supported, as well as many of the popular and most used libraries. So, not every single library will be included, but for the most part, if you're doing normal things and using popular libraries, PyPy will support it. And in the case that it isn't supported, PyPy includes CPython APIs, which can allow you to include libraries that will work with PyPy, even if they're not necessarily included in the installation. So one advantage that PyPy has over Python is it allows its users to experience features that are very similar to the ones that come with stackless Python. That stackless Python allows users to reap the benefits of thread-based programming without the performance complexity that normally comes with conventional threads. Um, Stackless Python is a small amount of features that add a great amount of convenience to your programming, and PyPy can give you the same thing. So if Stackless Python is something you use often, you won't have to go without it while trying to use PyPy. So downloading and installing PyPy is pretty simple. On the official PyPy website, you can download whatever version you want that's compatible with your machine, and if you're using Python 2 or Python 3, they have specific versions for that too. It'll give you a tar or a zip file, which you can uncompress, and you'll pretty much be able to run Python from there. So it's recommended on their website that you install the files in a virtual environment, and they do have a really good documentation page that helps install it and get it up and running with no issues. But it's really simple, takes a couple of commands, and then you've got it running. So the way you use it is, we've already seen in the previous example, but you can run it the same way you use Python, where you just type in PyPy and hit enter, and it'll bring up a very simple PyPy implementation. Just like with Python, you can type a couple of things, but it's not super useful for creating large programs in that way. Most of the ways that you're going to use PyPy is really the way you mostly use Python, which is have a pre-typed out Python program, and then you run it by using PyPy. So that's the way it's used best. So that's pretty much all there is to using PyPy to run Python code. As long as you know how to use Python already, using PyPy will be a breeze. It's just a bit more optimized for speed and memory usage in a lot of tasks. And installing extra libraries is done in the same way as with Python. You just use pip to do that, or whatever other way you were installing Python libraries. So the main cons and issues that people have with PyPy really stem from people that are coding obscure things and using much less known libraries and that aren't very common. So they do have an API that can help you use these, but it's not the best, and a lot of people have said that it's quite difficult to get those kind of libraries and stuff working. But other than that, using PyQt seems to be pretty good as long as you're doing things that it can optimize well. So let's move on to our second topic, which is PyQt. Uh, what is PyQt? Straight from their website, PyQt is one of the most popular Python bindings for the Qt cross-platform C++ framework. But to understand what PyQt is, you really have to understand what Qt all by itself is. So Qt is a widget toolkit that's used for creating graphical user interfaces and cross-platform applications that run on various software platforms like Windows, Linux, and Mac. They come with paid versions for companies and whatnot, but it also has free open source versions that anyone can use. So you have to install one of those versions of Qt and get that working first. Um, so installing it's super simple. You just use the command pip install pyqt, and you'll need to have a working version of Python installed as well um, in order to use PyQt. So using PyQt is simple, and they have some really great documentation on their website to get started in using it. It's pretty much just a library that you import. So as you can see in the code on the right at the top, it's imported from pyqt5.qt widgets. So this is a really simple example of using PyQt to open a plain graphical user interface window. This is what that window looks like. It's got nothing in it except for the title, Testing PyQt. But there will be plenty of more complicated examples in a little bit. So here's your more advanced example of PyQt. This is a snippet from their website, and it's more complicated. It shows that how to create a browser graphical user interface using PyQt. This is also object oriented, and it's a fully functioning browser that shows off plenty of useful libraries that come with PyQt. So this is what that browser looks like. Really simple, but it shows you how easily you can get into PyQt and just start creating something. So why would you use PyQt? A lot more can be done than just opening up a blank window like I showed you. Um, Qt and PyQt have been used to create some of the most popular and good-looking applications. Example being VS Code, Dropbox, and Eric Python IDE. VS Code and Dropbox being some of the most used, most known applications out there at all. And being well versed in PyQt and just Qt in general can be really good experience if you're looking for creating your own applications or working in a company that has applications that are created using these libraries and whatnot. Um, so one of the best things about PyQt is how simple it is to get started using it. For me, as someone who had never used or heard of it before, it pretty much took 15 minutes to get it downloaded and installed, and then one YouTube video to show me how to use some really simple parts of it to just get some stuff working. It's pretty easy to pick up and easy to create. They have a lot of helpful stuff that helps you create common things really easily. Uh, and like I said earlier, the documentation for it's very good. They have a lot of tutorials and code bases on their website that you can use um, to get started quickly. So here's an example of the Dropbox graphical user interface, which is created using PyQt. It's one of the most clean designs out there, and many other apps use PyQt as well. And these are my sources. Thank you for listening.